Okay, I wanted to finish up section 3.9 here in this video. We're talking about related rates, and I have a couple more problems left in this worksheet to show you. We're on problem 6. It says that a water skier skis over the ramp shown in the figure at a speed of 30 feet per second. How fast is she rising as she leaves the ramp? Okay, so here's the ramp, 15 feet across, 4 feet high. Okay. Now, let me call wherever she's at on the ramp. Okay, suppose it's this position here. She will be z feet away from the water, and she will be y feet above the water. Okay. Now, what do we need to find in the problem? It says, how fast is she rising as she leaves the ramp? Well, y would be changing. Z is also changing, but the fact that she's rising as she's leaving the ramp means that y would be increasing, so we need to find dy dt. Now, the skier is skiing over the ramp at a rate of 30 feet per second. They're telling me that dz dt is 30 feet per second, right? That's how z is changing. Now, in this problem, I want to use similar triangles, and I can do that, right? I've got a right triangle within a bigger right triangle. Both of these share a common angle at the tip. So this third angle right here is going to have to be the same. And the fact that I've got similar triangles means that I can set up a proportion. Okay, so y over z would be using the smaller right triangle. Match that with the height and the hypotenuse of the bigger right triangle. The height of the bigger right triangle is 4 feet. The hypotenuse would be found by using the Pythagorean theorem. I'd want the square root of the sum of the squares of the legs. So the square root of 15 squared plus 4 squared. 15 squared is 225, 4 squared is 16. 225 plus 16 is 241. Okay, so the square root of 241, that would be the hypotenuse of the bigger right triangle here. Let's go ahead and multiply both sides by z, okay, and so that way y is all alone. Now we got to find dy dt, and we know dz dt, so let's go ahead and differentiate both sides with respect to time t. Now you're going to have dy dt equals 4 divided by the square root of 241 times dz dt. dz dt is 30. Plug that in. 4 times 30 is 120. 120 divided by the square root of 241 feet per second, that would be the exact rate of change, or roughly 7.7 feet per second would be if you rounded the nearest one digit. Dy dt is going to be a positive, right? Because as she leaves the ramp, y is increasing. Now, y is not always going to be increasing, right? It's not like she just leaves the ramp and continues to increase. Okay, at some point she's going to reach a peak and then come back to the water. So at some point, dy dt will be a negative. Right immediately when she leaves the ramp, though, she's going to be rising, of course. So dy dt for this problem would be a positive. Let's take a look at problem 7 next. So it says a baseball diamond has the shape of a square with sides 90 feet long. If a runner on second base starts running towards third base at a rate of 20 feet per second, how fast is his distance from home plate changing when he is 60 feet from second base? Okay, so if he's 60 feet from second base, he's going to be 30 feet to third base then, right? Since each side of this square is 90 feet. Now, how fast is his distance from home plate changing? Let me call the distance from the runner to home plate u, and that's changing as he's running from second base to third base. U is getting smaller, right? So du dt would be a negative. X is also changing. The run is running towards third base, so x is getting smaller. That means that dx dt is a negative. Okay, well, I need to find du dt. Now, I'm working with a square. Of course, all angles are right angles. And I've got this right triangle then inside this square. So let me use the Pythagorean theorem as the equation to get set up here with what's going on in the problem. The sum of the squares of the legs equal the square of the hypotenuse. So for us, that's going to be x squared plus 90 squared equal u squared. Let's go ahead and differentiate both sides with respect to time t. So you're going to have 2u du dt equals 2x dx dt plus the derivative of a constant is 0. Now, dx dt is negative 20, right? The runner is running towards third base at a rate of 20 feet per second, so x is getting smaller, dx dt is a negative. And that, that statement here is basically them telling me dx dt. How fast is his distance from home plate changing when he is 30 feet to third base? X would be 30. Let me divide both sides by 2u. Of course, the 2's would cancel then. And that way du dt would be all alone. So you're going to have negative 20 times x over u. X is 30. U is the hypotenuse in this right triangle, and I can get that by using the Pythagorean theorem. I'd want the square root of the sum of the squares of the legs. So 30 squared plus 90 squared, I'd want the square root of that in order to get the hypotenuse. 30 squared plus 90 squared, 90 is the same as 3 times 30, right? So 3 squared times 30 squared would give me 90 squared. 30 squared is in common to these two terms. You can factor that out. And you get 30 squared times 10. The square root of 30 squared would be 30, and root 10 would be the leftover here. Okay, so 30 root 10, that would be this distance here, the hypotenuse of the right triangle. Okay, that'd be the value of u. Plug that in. The 30's cancel, and you get negative 20 divided by the square root of 10, or negative 2 root 10 if you were to rationalize the denominator. Now, that's a negative number, which is important. Okay, it's important to realize that dx dt is a negative. Okay, if I didn't write a negative there, that would have an effect over my answer. I'd have a wrong answer unless I were to give a statement along the lines of his distance is decreasing at a rate of 2 root 10 feet per second. Okay, so to avoid having to give any worded explanation at the end, let's just give our answer using this negative number here. Problem 8 is the last problem in this worksheet. And in all of my notes, I don't know if you've noticed this so far, but I'm trying to select problems that are different from the ones that you would see in the book. Some of them are just right from the book, okay, because quite honestly, they, some of them make for very good examples, and, that's the best one that I wanted to show you, okay, but I do like to give you, enough examples, and so I'm trying to select some problems that are, ones that are not in the book, but still obviously related to the topic that we're studying. And so if you want more examples with this stuff, I would encourage you to look at the book and see what examples there are in the book there. Let's take a look at problem 8. It says 2 people on bikes are separated by 350 meters. Person A starts riding north at a rate of 5 meters per second, and 7 minutes later, person B starts riding south at a rate of 3 meters per second. At what rate is the distance separating the 2 people changing 25 minutes after person A starts riding? Okay, I mentioned in the earlier video there, draw a picture. Okay, a picture is nice to have if you're a visual learner. It can help you get organized with what's going on in the problem. So we have 2 people on bikes, person A and person B. They're 350 meters away from each other. Person A is riding north at a rate of 5 meters per second. Person B is riding south at a rate of 3 meters per second. let me call the distance that person A has ridden x meters. And let me call the distance that person B has ridden y meters. Okay, so dx dt would be 5, dy dt would be 3. Now, at what rate is the distance separating these two people changing? That distance, I'm going to call that z. Z is going to be increasing over time, right? These two people are riding away from each other. So z is going to be growing, which means that dz dt would be the thing that I would have to find here, and that's going to be a positive when I get the answer. Okay, so that's what I have going on in this problem. Now, in this picture, let me extend this line to create a bigger right triangle, and the base of the right triangle would be 350 meters. The height of the triangle then would be x plus y, whatever that is, at a moment in time, and then the hypotenuse of the right triangle would be z meters. The fact that I've created a right triangle here allows me to then use the Pythagorean theorem. Nearly every single one of these problems are going to be where the equation that you're going to set up is going to be some like known geometric formula, okay, like a volume of a sphere, area of a circle, or something like that, or you're going to have to use like Pythagorean theorem or do something with trig functions. Okay, so we've seen all those different kinds of examples here in this worksheet. And so I'm going to be doing something with the Pythagorean theorem. I need to find dz dt. So let me set up the equation here using the Pythagorean theorem. The sum of the squares of the legs equal the square of the hypotenuse. That's going to be 350 squared plus x plus y squared equals z squared. Okay, now that I've got my equation here, let me go ahead and differentiate both sides with respect to time t. So I'm going to have 2z dz dt equals, you'll need a chain rule here, bring the 2 down, leave the x plus y alone, that's me to the first power, but then take the derivative of x plus y. Derivative of x would be dx dt, derivative of y with respect to time would be dy dt. Derivative of constant is always 0. Okay, so now we need to find dz dt. I could divide both sides by 2z. That way dz dt is all alone. Also, the 2's would cancel there. And I'm going to have x plus y over z times the quantity dx dt plus dy dt. Now I know dx dt and dy dt, right? That was information told to me in the problem. I need to get x, y, and z. So then I can plug in my information and I can get dz dt. X would be the distance that person A has ridden from the start point. Okay. Now person A is riding at a rate of 5 meters per second and has been riding for 25 minutes. Well, there's 60 minutes in an hour, or excuse me, 60 seconds in a minute, okay? And I'd want the minutes to cancel here. I've got 25 minutes, 60 seconds in 1 minute. The minutes units would cancel. Also, the person is riding at a rate of 5 meters per second. So seconds would cancel there, going to leave me with something in terms of meters. Person A has ridden 7,500 meters then in 25 minutes. Okay, now person B rides 7 minutes later than person A has started. So how far has person B ridden? Well, person B is riding at a rate of 3 meters per second. If person B has started 7 minutes later, that person has only been riding his bike for 18 minutes. There's 60 seconds in 1 minute, and so again, I'd like the units to cancel here so that I'm left with something in terms of meters. Well, 60 seconds in 1 minute, 18 minutes, the minutes units would cancel. 3 meters per second means that the seconds units would cancel, going to leave me with meters then left over. Multiply these three numbers and you get 3,240 meters then. That's how far person B has ridden. Okay, so I know x and y. To get z, I could use the Pythagorean theorem, right? Z is the hypotenuse of this bigger right triangle. And so z would be the square root of the sum of the squares of the legs. So I'd want 350 squared plus x plus y, that'd be 7,500 plus 3,240 squared. Okay, I want the square root of that to give me z. Z, when simplified, I was getting roughly 10,745.7 meters. Okay, so we have all of our information now. We know x, y, and z, and we can plug all this in. dx dt is 5 meters per second. dy dt is 3 meters per second. Let's see here, x plus y, when you add these two numbers, 10,740 meters. You're dividing by z, which is 10,745.7 meters. Okay, simplify, and I'm getting roughly 7.9958 meters per second for dz dt. dz dt is a positive, right, because z is growing over time as these two bikers are riding away from each other. All right, that's all the examples that I had in this section. Now this is one section that I would highly recommend doing all the homework problems. Okay, here they are on page 249. Students do sometimes struggle with the information in this section. Okay, the mistakes that I will see the most is that they will want to plug in things too early. I've mentioned that, or they forget a sign. You know, it should be a negative and they didn't write a negative or something like that. Okay, or they have troubles getting set up. Okay, so when you're trying to get set up, I would encourage you to draw a picture, unless a picture is given to you already, but use the picture to form an equation representing the situation, differentiate both sides, all the variables with respect to time t, and then plug in your known information, and be sure to include the units when you give the answer. Now, all of these problems are going to be where you're solving for a rate of change. So in all the problems, your answers are going to be like meters per second or feet per minute or radians per second or something like that. Okay, so take note of that, when you give your answer. It should be in terms of a rate. Okay, I'm going to go ahead and stop right there, and again, make sure that you look at the homework there on page 249.